Fox Chase Cancer Center was one of the first comprehensive cancer centers designated by the National Cancer Institute in 1974.
Well, we're taking a tour
Through the
Fox Chase Cancer Research.
Margaret is our tour guide.
Hi, Margaret. Hi, Margaret. In there, sequencing DNA.
It conducts basic and clinical research, programs of prevention, detection, and treatment of cancer and community outreach. The goal for Mrs. Baumgartner's class is to successfully defend the cell by cutting out the bar in DNA and cut it into pieces to make it non-functional. This process was done by a signal pathway, MAP kinase.
My name is Xiangxi Mai Su. I'm the principal investigator here. Everybody know Margaret, right? Is that? Yep. And Jennifer in the back there, she also assists to Osman working here for 5 years. They are very experienced scientists. And, Elizabeth over there, I think she's writing notes somehow. We have another person, Boris, who also trying to help. He's quite still in the gym. Right?
Day 1, PCR.
Here at the Fox Chase Cancer Center, where we research with PCR and DNA extraction and stuff. As you see, we're all pretty nifty. We got our lab coats on. We look like real scientists, and we're going to be really in depth today. So get ready for a good time.
The PCR procedure involved the DNA of ERK1 and ERK2. The DNA was amplified or replicated on a large scale.
What are we doing now?
We're going to add all the components in the mixture without using the template. Basically, each group is doing the same thing except for their template is different. So, right now.
Turbopolymerase was added to the ligated DNA because the turbopolymerase contained free nucleotides that attached to their nucleotide counterparts from the DNA.
Jesse, what are you doing?
Doing PCR right now, which is polymerase chain reaction, making the master.
Oh. See, just slowly drop it. Get it all out.
Gel to solidify.
Where's that gel? There it is. That's what they look like when they're done.
This is the UV light machine. As layman's terms, the real term is, what is it? The real term. Illuminator. And you can see the DNA.
Oh, okay.
So that's what it looks like. And this is how this one comes out.
Day 2, transformation. The genes were inserted into the plasmids, and the plasmids were mixed with bacteria. The bacteria replicated, and the transformed genes were inserted into each one of those.
Can I leave them in the ice, or should I take them out?
Yeah, leave them on ice. You want to change your tips because you're going to go to different plasmids.
Then the plasmids were mixed with bacteria. The bacteria were then grown, and electrophoresis was used to ensure that the gene had been successfully inserted into the plasmids.
In that packet we got when you guys came to school, the greens and all that. Yeah, right. That's the fluorescent tag. Right, I got that.
Second. So you can see the electric current is right. So tell me how a little bit of that one's empty, so that's what I'm putting.
What's crazy?
I like being in a lab. It's a lot different than being in a high school lab table.
Yeah. How much is
Yes, same thing.
I was thinking that. Start seeing all of the stuff. Yeah, makes more sense.
Okay, good.
And
of them. Take both of them.
At the same time?
Yes, this is multitasking.
Are we just like dropping them in?
No, you're going to have to hold them.
Oh, okay.
All right, ready?
Day 3, protein purification. We started with plasmids containing EGFP, ERK1, and ERK2. Then we used lysates to break the plasmid membrane so it was easier to separate the proteins.
We're here at Fox Chase Cancer Center in Dr. Chu's lab, and with working with a lot of scientists there.
The solution was then centrifuged to separate it further, and then strained through a special nickel column to further isolate the protein. The flow-through and the wash were saved to be tested for the protein by protein electrophoresis.
Very nice, okay? To the bottom.
You just have to tap down once.
We assembled a gel apparatus and we're preparing to put this liquid, which is made out of 90 milliliters of water and 50 milliliters of buttercup.
Right now, we have our protein lysates all ready to go. It's all mixed up, and we just separated them both into two Effendorf tubes. Right now, we're getting ready to centrifuge them. When we centrifuge them, they'll be separated into pellets and lysate, and lysate will extract the protein.
Day 4, Western blotting. We detected specific proteins that were separated by electrophoresis and by the use of antibodies. We washed the membrane from group 3 in the primary antibodies. It was then placed on the belly dancer and washed in a buffer solution. We used 3 secondary antibodies in a solution. Once the membrane was washed a few times, we wrapped in saran wrap with a peroxide buffer and a luminol enhancer solution. We went to the dark room and taped the saran-wrapped membrane to a piece of film and placed it in the film cassette. Finally, we marked the proteins according to the bands we found.
Overall, Fox Chase was a success. It was educational for both students and lab staff members. The most significant aspect learned at Fox Chase is cancer research and finding a cure. This goal is not easily obtained, and this field trip was a definite eye-opener to understanding how labs operate.